Hey there everyone, my name is Zach Babbitt and this is a brief video I made about special relativity. I have also made a much longer video describing special relativity in depth, but it turned out to be 17 minutes long. So I made this brief video that is an overview of everything else that's in that longer video. So you can watch this, and if you're interested to know how everything I talk about in this video works, then you can click on over to the other longer video. And if not, then you can just stop here. Thanks for watching. Briefly, let's talk a little bit about reference frames. So, as we've all known since grade school, you can't measure velocity or motion relative to just one object, but rather you have to have another object against which you can compare it. And it's long been known that the definition of those reference frames can change how we perceive motion. So, for instance, if someone's on a boat and they're moving parallel to the shoreline, and there's someone on that shoreline that throws an arrow at the person on the boat when the person on the boat sails by, the path of the arrow will appear different to both observers. The person on the boat will see the arrow curve away from them as they sail past, but the person on the shore will see the arrow move in a straight line as the person sails by them. And so this just goes to show that for millennia in physics, there was a precedent that variables and perceptions of those variables can be different based on different perspectives. However, for a very long time, that was only really applied to motion, but not necessarily velocity per se, which is what the special theory of relativity deals with. Time for a brief history of science lesson. Basically, leading up to Einstein's thought experiments, what led him to think about the nature of the universe in his patent office was the Michelson-Morley experiment. Long story short, it was an experiment to try to find the medium through which the wave of light was supposed to travel, because at the time it was thought that since light is a wave, it must have a medium in which it travels. And this was supposed to be an experiment to detect that medium, supposedly called the ether. They didn't find it, and it was a big deal, and it was a massive failure. And so, trying to resolve some of the scientific gaps left by this failure, Einstein devised the following thought experiment. Now, here I just talk about the setup and the conclusions, but I have a pretty in-depth and cool look at the derivation of how Einstein got from point A to point B in the longer video. This is a brief preview of that video. I will walk you now through the setup for this thought experiment. To begin this experiment, Einstein first imagined a contraption where a photon was emitted from a source, reflected off a mirror, and then what was reflected back into a receiver. And every time that happened, a clock ticked once. And then he imagined this contraption on a train whizzing by a platform with an observer both on the train and on the platform. And so these two diagrams show the difference in setups. From the train view, the photon just shoots straight from the emitter, bounces off the mirror, and back into the receiver. However, for the viewer on the platform, it is emitted here, travels this distance, reflects off the mirror, travels off this distance, and then is received over here as a result of the fact that the train is moving past the platform. So Einstein was able to leverage this thought experiment to find a conversion factor between the time experiences of objects moving at near light speeds and the time experiences of objects at rest. He was able effectively to prove that as one approaches the speed of light, everything else around them speeds up, everything else that's not moving at the speed of light speeds up, and that for those that are motionless, the relativistics are happening at a slower rate. And I explain how that works and why in the other video. But if you just wanted to know some extent of what everyone else is talking about at parties, then you're done. This is all you needed to watch.